Hello everyone, in this video we will learn how to graph the tangent function. Alright, so we know that the parent function of the tangent function is going to be f of theta equals tangent of theta. Alright, so the tangent function of theta is odd because it's symmetric about the origin. So then you have tangent of negative theta equals negative tangent of theta. The period of the tangent function theta is pi, meaning the values of the tangent function repeat itself after the length of pi. Why? Take a look at the unit circle. We know that tangent is the slope of the terminal rate, right? So the terminal rate right here, the slope is rise over run, right? So this is rise, this is run, right? And we use the Christmas tree trick. If the lines go in this way, the slope is positive. The lines go in this way, the slope is negative. The line is horizontal, the slope is 0. The line is vertical, the slope is undefined, right? Since the terminal rate in the first quadrant, right? And it's going this way, the slope is positive, right? Actually, rise over run is positive, right? So now if the terminal rate in the second quadrant, and then it's going to be this one right here, right? And then the slope is negative, right? Of course, if you draw the rise and run, you will see that it's negative, right? Now, if the terminal rates go to the third quadrant, the slope of the terminal rate is positive again. If the terminal rate go to the fourth quadrant, the slope of the terminal rate is negative again. Alright. And you see that every single half unit circle, the sign of the slope repeating, right? This one is 0, this one is pi, right? You have the positive slope, negative slope, and then positive slope, negative slope again, right? So the period of the tangent function is pi. Now, when the terminal rate is vertical, right? So when the terminal rates go over here, and you know that the point right here should be 0, 1, right? And when the terminal rates go over here, and you know that the points right here should be 0, -1, right? Now at this angle, it should be 3 pi over 2, counterclockwise direction, or negative pi over 2 if you go with clockwise direction, right? This one is pi over 2, right? So you know that tangent of pi over 2 is y divided by s, right? The y value is right here. S value is 0, right? So 1 divided by 0 is undefined. Now, tangent of 3 pi over 2 is still -1 divided by 0 is still undefined, right? So because it's undefined for pi over 2 and 3 pi over 2. Now if you keep moving the terminal rate counterclockwise, you see that this one is pi over 2, this one is 3 pi over 2, this is 5 pi over 2, this is 7 pi over 2, 9 pi over 2, 11 pi over 2, 13 pi over 2, and 15 pi over 2, and etc. Right? So these are vertical asymptotes of the tangent function. In general, if theta equals pi over 2 plus k pi, and then tangent theta is undefined, these undefined values are vertical asymptotes of the tangent function. Now we have the standard function of the tangent function. It's going to be f of theta equals a times tangent of b theta minus h plus k, or sometimes you see this form, right? In the tangent function, amplitude, maximum, minimum, and midline should be undefined. So keep that in mind. Alright, because the tangent function keeps going up and going down right here, there is no maximum, no minimum. Therefore, there is no amplitude. Alright, there is no midline. Now, the period of the tangent function is going to be pi divided by b, right? If you have the value of b right here. Now, in the parent function, b should be 1. That's why the period is pi, because pi divided by 1 should be pi, right? Now, the vertical asymptote of the tangent function is going to be pi divided by 2b plus k times pi over b. Alright, when we learn how to graph it later, I will show you how, right? The phase shift is the horizontal translation. If h greater than 0, it shifts to the right. If h less than 0, it shifts to the left, right? The vertical shift is the value of k, or d right here. If k greater than 0, it shifts up. If k less than 0, it shifts down. Horizontal dilation by a factor of 1 over b. If b less than 0, it reflects over the y-axis. Vertical dilation by a factor of absolute value of a. If a less than 0, it reflects over the x-axis. The tangent function is monotonically increasing. The graph of the tangent function is changing from concave up to concave down. You look at this one, this is concave down. And this one right here is concave up, right? Between two consecutive vertical asymptotes, right? This one right here and this one right here are called two consecutive vertical asymptotes. The inflection point is where the graph changes concavely. So we have the inflection point is going to be right here, and right here. Alright, the domain of the tangent function is all real numbers except the vertical asymptotes. So you need to exclude the vertical asymptotes. The range of the tangent function is all real numbers. Alright, now we're going to learn how to graph the tangent function. Now let's take a look at the first example. For example, we need to graph f of s equals 2 tangent of pi over 8s. Alright, in this situation, we have no horizontal shift or vertical shift, right? So we need to identify the vertical dilation. So a equals 2, right? And the period is going to be pi over b. b in this situation, pi over 8, right? So it could be pi over 8. So it turns out to be pi times 8 over pi. And then pi and pi cancel out, so the answer should be 8, right? Now, once you have the period, you take the period divide by 2 to get 2 vertical asymptotes. Right, so 8 divided by 2, 4, right? So you have the first 2 vertical asymptotes. It's going to be the left and the right, right? So plus 4 and minus 4. Now keep in mind, when you take period divided by 2, number 2 right here doesn't come from here. Number 2 actually come from this formula right here. Alright, so you have the first 2 vertical asymptotes. It could be plus and minus 4, right? So you're going to draw the vertical asymptotes right here and right here. Alright, now next we need to locate the inflection point. Alright, now keep in mind the inflection point is the midpoint of the distance between 2 consecutive vertical asymptotes, right? So the midpoint should be right here because we don't have the vertical shift or horizontal shift, so it should be on the x-axis, right? Now next one, we need to locate 2 more points, right? Now the point on the right here, we're gonna locate the halfway of this one, right? The distance from here to here, 4, right? So halfway should be 2 right here. And then we look at a right here. A equal 2, so you just go up by 2, right? So it's gonna be right here. Alright, same thing. On the left hand side, you go down by 2. So it could be right here. Now you just connect these 3 points and you get the graph of the tangent function, right? Remember that it's not a straight line, right? It should be concave up right here. And this guy should be concave down right here. Now, what if we have the negative side in front of 2, right? And then the function reflects over the x-axis, right? So this guy right here becomes the point right here. This point right here becomes the point right here. And then the inflection points stay, right? And then you just connect these 3 points. Now let's move on to the next example. For example, we need to sketch f of s equals negative 2 tangent of pi s plus pi minus 1, right? Now first step you need to do is to check to see if this one in the standard form, right? The standard form must be this, right? So it's not a standard form, we need to convert it to standard form, right? So it should be f of s equals negative 2 tangent of, you need to factor pi out, right? So pi times s plus 1 and then minus 1, right? Now we need to identify all the values a, b, c, and d, right? So we have a equals negative 2, right? It tells us that this is the vertical dilation by factor of 2, and there is a reflection because you see the negative side, right? And then next one, you have b equals pi, right? So after you have p, you need to calculate the period, right? So the period should be pi over b. So it's going to be pi over pi. So it's going to be 1, right? And then in order to find the vertical asymptote, you take the period divided by 2. So vertical asymptote is going to be 1 divided by 2, right? And you put the plus and minus side right here. It tells us that the first 2 consecutive vertical asymptotes are 1/2 and negative 1/2, right? Now d equals negative 1, which means there is a vertical shift down 1 unit, right? Alright, so we need to locate 2 vertical asymptotes at 1/2 and negative 1/2, right? Now next one, you need to locate the inflection points, right? So after you have the 2 vertical asymptotes, now you need to look for the horizontal shift, right? So horizontal shift right here, c equals negative 1, right? C equals negative 1 is shift to the left 1 unit. So you just shift 2 vertical asymptotes right here 1 unit to the left, right? So it turns out to be like this, right? Now next one, we're gonna check for the inflection point. The inflection point is the point on the x-axis that between 2 vertical asymptotes, right? So actually inflection point is going to be right here. Now because there is a vertical shift down 1 unit, right? So inflection point must be shifted down 1 unit, so it turns out to be right here, right? So this is the inflection point. Now we need to look at the vertical dilation right here. Right, a equals negative 2. We look at the positive 2 first, right? Now, in order to locate a equal 2 right here, we're gonna divide the distance from here to here into half, right? So it should be right here. And then we go up by 2 units, right? So it's gonna be half, 1, 1/2, and 2. So it's gonna be right here. Alright, now same thing. On the left hand side of the inflection points, you need to divide the distance from here to here in half, and then you go down by 2 units, right? So 1, 2. So it's gonna be right here, right? Now, next one, we look at this one, we see that there is a subtraction sign in front of the value of A, right? So there is a reflection. So this point right here becomes this point right here. This point right here becomes this point right here. Alright, now you just connect these 3 points. Alright, and that is the graph of this tangent function. Now let's take a look at this example. f of theta equals 1/2 of tangent 2 theta minus 3 pi over 2 plus 2. Right? And we look at the standard form right here. We see that it's not the standard form, right? So we need to convert this guy into the standard form, right? So we have f of theta equals 1/2 tangent of parenthesis 2 parenthesis theta minus 3 pi over 4, right? We just factor 2 out and then plus 2, right? Now, we need to identify the vertical dilation, right? So we have A equals 1/2, right? And the period is going to be pi over B, right? Now B equals 2, so it turns out to be pi over 2, right? After you have the period, you take the period, you divide by 2, right? Now 2 is not this number, 2 is from the formula right here. Alright, so the vertical asymptote should be plus and minus pi over 2 divided by 2. So it should be plus and minus pi over 4, right? Now we have a phase shift, it's going to be 3 pi over 4, right? And it's shift to the right because you see subtraction sign right here, right? So the phase shift is going to be C equals 3 pi over 4. So the new vertical asymptote should be pi over 4 right here. You're going to add 3 pi over 4. So it turns out to be 4 pi over 4, and you simplify, it turns out to be pi, right? And negative pi over 4. So then you have negative pi over 4 plus 3 pi over 4. And then it turns out to be 2 pi over 4. And it's going to be pi over 2, right? And you have the vertical translation. It's going to be D equals 2, or vertical shift, right? And then now we're going to sketch the vertical asymptotes first, right? So vertical asymptote should be pi and pi over 2 right here, right? Now, after you have 2 vertical asymptotes right here, you just duplicate this one and you have a bunch of vertical asymptotes, right? Now, after you sketch all vertical asymptotes, right? And then you need to locate the inflection point right here, right? Inflection point is the midpoint between 2 consecutive vertical asymptotes, right? So normally inflection point should be right here, right? Right here, right? Now, because you have the vertical shift 2 units up, right? So basically you need to shift the inflection point up 2 units, right? So it's going to be right here, and it's going to be right here. Now next one, we need to find the other 2 points so that we can connect them, right? To get the tangent function graph, right? So look at the inflection point right here and the next vertical asymptote that's close to the inflection point. So I look at this one right here. We're going to locate the points that have a distance from here to here, right? So it could be right here, right? And then we're going to go up by 1/2 right here, right? So go up by 1/2, so it should be right here. And then on the left hand side, you should go down by 1/2, right? So it should be right here. And similarly, you do the same thing for the rest points. Now, the last step is to connect these 3 points right here. Alright, you may use Desmos to check your work, right? Now let's move on to the next example. So for example, if I have the subtraction sign in front of 1/2 right here, right? So it's actually there is a reflection, right? This point right here becomes this point, right? And then the reflection point stay. So keep that in mind, all reflection points stay. This point right here becomes this point. This point right here becomes this point. Now what you need to do is to connect these 3 points, right? And observe that the first graph is the one with positive A values right here, right? So the graph right here is monotonically increasing, and if A is negative, it is monotonically decreasing, right? And it's good time to stop. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand